Welcome to Almost Scientific Notation, a bittersweet tale of numbers fighting for justice. In our section today, we'll be talking about two different numbers that are fighting for justice. The first is found in the expression in sample 1. They keep pulling me down, but I want to rise up. We have the expression 12.2 times 10 to the negative fourth, seemingly in scientific notation, and yet it's just not good enough in this instance. The 12.2 is larger than 10, and therefore in scientific notation is rejected. We need to convert it to a value that still maintains its value, but doesn't have it in the form of 12.2. So taking a look at what would be equivalent and giving us what we need, we can move the decimal place one place to the left and get 1.22. But 12.2 doesn't want to be demoted to a lesser value, so it's going to fight back. 1.22 is not big enough for 12.2, so it's going to multiply by 10 to the first power, since we're moving the decimal place to make it smaller by one place value. Substituting 1.22 times 10 to the first into the original equation, we get what follows: 1.22 times 10 to the first times 10 to the negative fourth. And then we use our friend the associative property to make this expression look a little more familiar. And we see some familiar monomials that we are able to multiply quite easily. When we multiply monomials with the same base, of course, we add the exponents, so we end up with 1.22 times 10 to the negative third. Now the question is that really equal to 12.2 times 10 to the negative fourth? If we take a look at 12.2 in the original expression, and we multiply it by 10 to the negative fourth just to get it in standard form, that would mean moving the decimal place 4 places to the left. When we do that, we get the number 0.00122. Well, let's look at 1.22, which is in our changed expression. If we move that to indicate the 10 to the negative third, if we move that decimal place, we end up with 0.00122. Same value, just a different representation of it. Sample 2 discusses I'm so small, but they're trying to make me bigger. Here we have 0.0534 times 10 to the third. Not in scientific notation because 0.0534 is less than 1. If we compare it with some different values, or if we take a look at the number and see how we can manipulate it to keep the value but change the format, we can change this to 5.34 times 10 to the negative second and still have the same value. Now why negative second? Well, this is a small number and you're trying to make it bigger to 5.34. It's resisting that because it's just not its value, so it's going to try to pull that decimal place to the left. And in doing so, to balance that out, it's going to pull it negative two places, basically. Substitute in 5.34 times 10 to the negative second, and then that quantity times 10 to the third from the original expression. Use our friend the associative property like in the last sample. And when we evaluate our monomials, we find 5.34 times 10 to the first. Now again, doubting whether we're right or not, we'll take the original decimal, 0.0534, and make it into standard form, times 10 to the third, move our decimal 3 places over to the right, and we get 53.4. If we take 5.34, which is in our answer, and multiply it by 10 to the first, we move the decimal place 1 place to the right, and we end up with 53.4. So ends our saga. Until next time.